if we make this north, as is custom, then this boat will have traveled 80 kilometers, 80 nautical miles to the east and 192 nautical miles to the south. Let's pretend that those are exactly 90 degrees from each other, as east and south are. The distance that this boat has traveled then would just be equal to the distance traveled in the first leg plus the distance traveled in the second leg, which is equal to 272 nautical miles. Its displacement, however, is different. Its displacement is described by a vector going from the very beginning of the trip to the very end in that direction. And so its displacement can be found, since this is a right-angled triangle, using the Pythagorean theorem. So here's delta d. This line here represents the displacement of the boat. So let's take a look at that. If displacement, which is the hypotenuse of this triangle, represents c, then that squared equals 80 nautical miles squared. And we're squaring the whole term plus 192 nautical miles squared, which means that delta d equals the square root of 6,400 nautical miles. The units are now squared, which is 36,864 nautical miles squared, which means that our delta d is equal to 208 nautical miles. And so the magnitude of the displacement of this boat is 208 nautical miles. However, displacement being a vector, we need to find its direction. And so what we're going to do, in this case, we're going to find this angle, and that'll help us find the angle, the direction of travel of this boat. If, after we find this, we just report the angle, this is going to be probably about 70-ish degrees. If we just say, let's say it came out to 70 degrees, if we just reported 70 degrees, that would not be correct. This angle is going to help us find the direction of the displacement. This angle that we find is not necessarily going to be the direction of travel itself. So let's take a look and find that theta. And so if we wanted to find theta, we could, we've just found this. We've just found the length of the hypotenuse, which is 208 nautical miles. My suggestion would be to use the given values, because if you by chance did make a mistake over here, that mistake would carry through in the angle calculation. If you use the given values, that's not going to happen. And so, given that we can use the opposite side relative to the angle and the adjacent side, we can use trigonometry, we can use the tangent function in order to find that angle. And so the tan of theta equals the length of the opposite side, which is 192 nautical miles, divided by the length of the adjacent side, which is 80 nautical miles. And working that out gives us a theta of 67.4 degrees. Now, again, that 67.4 is just the angle between these two lines. It is not the direction of displacement. And so let's see, how can we report that? Here's our displacement. It equals 208 nautical miles in the direction which is indicated by these square brackets. You could say this a lot of different ways. This is, you could say 67.4 degrees south of east. You could say, with respect to the compass, that's 0. On the compass, east is 90 degrees, south is 180 degrees, west is 270. On the compass, this would be 67 degrees past 90, which would make it 157.4 degrees as a heading. You can describe the direction in multiple different ways. All of them are acceptable in terms of this course, as long as you're clear as to which, as long as you're clear and correct as to which direction you mean, that's fine. Part 2 of this question asks, if your average speed, or if the average speed of the boat was 80 nautical miles per hour, then what is its average velocity? Now, let's examine that. We have a couple of equations that we can work with. Average speed, which equals distance over time. Average velocity, which equals displacement over time. Now, we're asked to find average velocity. If we are to do that, then we need displacement, which we just found, 208 nautical miles in the direction, in one of these directions, those directions being the same as each other. So we have that. We need time. We don't have it yet. We don't know how long it took this boat to make this journey. However, if we look at our other equation, we can see that we have an average speed that's 80 nautical miles per hour. That just comes from the question. And we also have a distance. And so with only one variable missing from this equation, we can isolate for that variable and come up with a value for it. Then we can take that value, plug it back into this equation to give us the average velocity. And so we look at our tools, we say, all right, average velocity. In order to find average velocity, we need displacement and time. We don't have time. Can we find it? Yes, we can use this other equation to find the time to plug into this second. Okay, so let's do that. If we are to rearrange this to isolate for t, we need to get this t in the numerator of a fraction, or at least out of the basement over here. So let's multiply both sides by delta t times delta t. So v average times delta t will equal distance. And now delta t is being multiplied by average speed, and so we can divide both sides by average speed. And so we get a delta t equaling delta d, because these cancel, divided by average speed, which equals 272 nautical miles divided by an average speed of 80 nautical miles per hour. Now, remembering that this is a rate, 80 nautical miles for every 1 hour of travel time, dividing by this means multiplying by its reciprocal. So let's look at this carefully, only so we can account for the units. We're going to take this 272 nautical miles and multiply it by the reciprocal of this number here. So 1 hour over 80 nautical miles. The units of nautical miles, will cancel, and we get an answer of 3.4 hours. Hours are the only units that are left over, and thus appear in the answer. That's our delta T. So we have a displacement of 208 nautical miles in the direction 67.4 degrees south of east. And we have a delta T of now 3.4 hours, which we just found. And now we can use those figures to find our average velocity, which is equal to displacement divided by time. Displacement of 208 nautical miles divided by 3.4 hours, and we get a final answer then of 61.2 nautical miles per hour. Now, because this is a displacement, it'll come with a direction. And because this has a direction, because the displacement has a direction, our average velocity will also have the same direction. In terms of the information, given what's a vector and what's a scalar, here's one vector, the one displacement, the first leg. Here's another vector, the second leg. We're given an average speed. We're given an average speed, which is a scalar. And in our answer, we found an average velocity, which is a vector. And we found a displacement, which is also a vector. Next up, we will talk about acceleration. Acceleration being defined as the rate of change